Good evening, guys. So in this lesson for today, we are going to be looking at enzymes. Enzyme is a very short topic and interesting one. And under this topic, our aim is to understand the following: being able to define an enzyme, stating what an enzyme do, and state a number of characteristics that enzymes possess. Then from thereafter, we'll discuss one or two characteristics of enzymes. Then we'll look at the factors that affect enzyme activity. After that is done, we are going to conclude this lesson by looking at the industrial applications of enzyme. So to begin our lesson, we will need to define what an enzyme is. So an enzyme, specifically or in simpler terms, we'll say an enzyme is a biological catalyst protein in nature. This is a simple definition. Now, in as much as we've said an enzyme is a biological catalyst protein in nature, it is important for us to understand this definition. One, the key terms in this definition is that enzymes are biological catalysts. So there is a biological, there is as well as a catalyst, and protein as well as nature. All these words are important in this definition. So one, enzyme must be biological, meaning they should be existing in living organisms. Then a catalyst is specifically a substance that speeds up a rate of a chemical reaction without themselves being changed. A protein specifically will be that of a nutrient that exists in a living organism. Nature meaning it will exist in its natural state. So this is the basic definition of an enzyme, as we are defining it to be a biological catalyst protein in nature. Please take note that when you define an enzyme to be a catalyst protein in nature, it is totally wrong, because an enzyme has to be a biological catalyst. So now, enzymes can be categorized in two different types. So we'll have those enzymes that work within or inside a living organism, which are called intracellular enzymes. Then those enzymes that work outside a living organism are called, or outside living cells are called, extracellular enzyme. Now that we've defined and categorized the two types of enzymes that are there, let us now try and understand what enzymes do. So what do enzymes do? So here it says enzymes speed up a chemical reaction in living organisms without being chemically changed at the end of the reaction. That is what it means from this definition. So enzymes are there to speed up the rate of a chemical reaction. At the end of that chemical reaction, this enzyme will not be chemically changed. It will continue being an enzyme, meaning that enzyme can take part in many different types of chemical reaction. For instance, if we have an enzyme called pepsin, this enzyme will take part in one chemical reaction. At the same time, it can take part in another reaction. At the same time, it can take part in another different type of reaction. So it is important for us to understand that enzymes are there to speed up the rate of a chemical reaction without them being changed. Now, from discussing what an enzyme is and what enzyme do, it is now from this point in time that we can make now a full complete definition of an enzyme, which will be that enzymes are biological catalysts, protein in nature, that speeds up chemical reaction in living organisms without them being changed at the end of the reaction. That will be the complete definition of what an enzyme is. Now, let's proceed again. But as we proceed, let's try and take note, because we have to identify which parts of an enzyme, or which is an enzyme, or how does these chemical reactions that an enzyme would be taking part come about to be possible. So here is a bit of this diagram that I have drawn. So as you can see from this diagram that I have drawn, specifically we have three things that we need to take note of. One, there is this top part which we are calling a substrate. Then we have this all thin which we are calling an enzyme. Then we have where it is pointing to show us an active site. Now, a substrate is the one that goes in an active site. So it binds in the active site of an enzyme. Now, when this substrate binds in an active site, it is now that an enzyme is ready to take part in a chemical reaction. So an enzyme, or there will be three parts that we will need to take note of. So one, we have the substrate, the active site, as well as an enzyme. So these three are important to be taken note of. So the substrate will bind in the active site of an enzyme for it to take part now in a chemical reaction. Now, let us look at the characteristics of enzyme for us to appreciate this diagram. So here are some characteristics of enzymes. They might be just a few, but not many. I will mention 1 or 2, 3 that are not here that will help us understand. So one characteristic of an enzyme is that enzyme will always be proteins in nature. That is one. 2, they are catalysts. Why? Because they speed up the rate of a chemical reaction. Because we've defined a catalyst as a substance that speeds up the rate of a chemical reaction. Then third, this one is very important. We need to take note that they are specific. Enzymes are specific, meaning that an enzyme will work on a specific type of substrate. So if we have a substrate like this one, this substrate can fit in this one, meaning that this enzyme will make a complete enzyme for it now to proceed in a chemical reaction. That is why we mean enzymes are specific. Or a practical example that we can give of an enzyme to be specific is that of a key and a lock. Each key has got a specific lock that it can unlock as well as the lock. Even enzymes work in that kind of mechanism. It is not every enzyme that will work on a particular substrate, no. It is not every substrate that will work on a particular enzyme, no. But a specific substrate will work on a specific enzyme, just like the way a key will open a specific lock. That is what it means. Now, we are saying again that enzyme catalyze both forward and reverse reaction. What this means is that if an enzyme takes part in a reaction where you want to produce products, at the end of the reaction, it will continue being an enzyme. So again, if those products were to react to form the reactants, again that enzyme will catalyze that reaction, meaning it is catalyzing now a backwards reaction. So meaning enzymes are able to catalyze both forward and reverse reaction. Now, the last point here is that enzymes are affected by the activity of pH as well as the temperature. What does this mean? So what this means is that the enzyme activity will be affected by the temperature. So if there is less temperature or the temperature is low, an enzyme will behave in a certain way. If the temperature is high, an enzyme will behave in a certain way. The same applies for the pH. An enzyme will be working specifically in a certain way depending on the pH where it is, or depending on the environment of the pH at that particular time. So enzymes, again, we can say they are denatured at high temperatures. So temperatures of above almost 55, of about 55 going up, you find that enzymes are denatured. Now, what does this mean when we say enzymes are denatured? So let us try and look at this diagram that is showing the activity of an enzyme as temperature increases. So in this picture, we have temperature, which has number one as one of the factors that affect the rate of an enzyme. So if you see here, we are saying there is rate of an enzyme reaction, then here is temperature as it increases. So if you see here, it's 0, but as temperature increases, even the graph of an enzyme will increase, meaning the rate of an enzyme is increasing. So meaning as rate of an enzyme is increasing, even temperature is increasing on the other side. But as it reaches this point that shows the dotted line, what this means, or at this point which we are calling an optimum temperature, it means this is a point at which an enzyme will be working best, at the point at which an enzyme will be very active. So now, beyond this dotted line going this side, it means an enzyme, meaning an enzyme will be denatured because the temperature continues to increase. So at excess temperature, an enzyme will get denatured. Now, what do we mean when we say an enzyme will be denatured? What we mean is that at high temperatures, an enzyme is denatured, meaning an enzyme will lose its biological function. So that's to an extent where if this substrate comes to fit in the active site, it won't fit because an enzyme has lost its biological function, its biological shape. It will be unable to perform. It will be unable to do anything because this substrate can no longer fit in this enzyme because it has been denatured. That is what it means. So the optimum temperature is a point at which an enzyme will be working best. Now, when we look at the second one, which is pH, first we need to understand the pH and how it looks like. So this is a scale that shows the pH. So at 7, we have what we call natural or neutral. So here it's supposed to be natural or neutral. So neutral is at 7. So at the pH value of 7, it is neutral. It is neither acidic or it is neither basic. But as we move from 7 going to 8, 9, 10, 11 up to 14, an enzyme is in a basic medium. Then as we move race by 7, meaning 6, 5, 4, 3, 2, 1, going to 0, an enzyme will be in acidic. There are enzymes that work best in acidic medium, as well as enzymes that work well in basic medium. The pH value will vary depending on the levels of acidity in that particular medium or the levels of basicity in that medium. Now, how does the pH affect the activity enzyme? So looking at this value, the pH is increasing from this angle while the enzyme rate activity increases. So as the pH increases, even the rate of an enzyme increases. But to what extent is what we should take note. So here where it is showing the dotted line, it is the optimum pH. Just like we said for temperature, even in pH, an enzyme will have an optimum pH. And an optimum pH is a point at which an enzyme will be working best. At this point, an enzyme will be very active. So as the pH value increases, even the rate of an enzyme will increase depending on the medium in which it is working, if it is in acidic or if it is in basic. Now, in concluding this lesson, I want us to look at the applications of enzymes. So there are various industrial applications of enzymes, among which the following are: enzymes are used in making biological detergents. The soap that we use normally at home for washing some of the plates, all those products, enzymes are added. and as enzymes are added, it makes the reaction faster. That is why we see when we are washing clothes, when immediately we just squeeze the cloth from here to there, the cloth is already clean because of the presence of enzymes that speed up the rate of chemical reaction to remove biological stains. The second one is that enzymes are used in brewing as well as baking. The way we normally enjoy our scones, some buns, and the way other people will be enjoying the beer, that alcohol, enzymes are added to all those things. At the end of the day, we have a product. Enzymes are as well used in tanning of leather. The leather, you normally have leather coats, leather shoes from animals. So for them to be used to make those coats as well as shoes, they need to apply enzymes. And the last one is that enzymes are used in the dairy industry. This includes making of sour milk, yogurts, all those things enzymes are added to. At the end of the day, we'll be enjoying. This shows that enzymes are very important to our daily lives. So this was a short lesson on enzymes. I hope you find it interesting, and that if you have any questions, please feel free to post in the group.